Hi everyone, my name is Lachlan McNamara and today I'll be presenting my project titled Predicting the 2025 AFL Final Series. This study uses statistical modelling and simulation to forecast match outcomes and grand final results in the AFL. I'll show you how I built and compared 4 different predictive approaches from logistic regression to Monte Carlo simulation and how well they performed. This project investigates AFL team performance over the past decade from 2015 to 2024 to understand what drives final success. The data was built from AFL season statistics, focusing on the most recent 10 years to capture the modern style of play. Faster, more tactical, higher scoring. I use techniques like ELO rating systems and logistic regression models, which are commonly used in professional sports analytics to estimate win probabilities. By developing and comparing multiple models, the goal was to evaluate which approach best predicts match outcomes, winning margins, and ultimately the grand final result. In short, the motivation behind the study is to apply data-driven methods to one of the most unpredictable sporting events in Australia. So, the data was sourced from AFL tables manually, including all finals matches from 2015 and 2024. I focused on team level statistics like goals, behinds, total points, and defensive metrics as variables I wanted to test for the statistical significance against predicting match and margin outcomes. All of these variables I captured are shown here in table 1. So team and opponent, pretty self-explanatory, we need to know who's playing. Type, the type of final, elimination final, qualifying final, grand final. Ladder position and previous ladder position, where did they finish last year? Finals experience in the last 5 years, self-explanatory. Wins, draws, losses, how well do they do in the season? Goals, behinds, and the goals, behinds ratio, how good are they at attacking? Goals against, goals, behinds against ratio, how good are they at defending? Round exit, when did they exit the finals? Losing margin, how much did they lose by when they did exit? And ELO. Each team received an ELO rating, which is a dynamic measure of long-term performance that adjusts for match difficulty, finals bonus, and score margin. These variables became the predictors used to estimate win probabilities, margins, and finals outcomes. So, I developed 4 different models to predict the 2025 finals. Model 1 is a logistic regression predicting win probabilities from ELO, ladder position, and defensive stats. Model 2 is an ensemble of 50 logistic models, each trained on different bootstrapped samples to smooth out randomness. Model 3 is a linear regression that estimates how much a team wins by. And Model 4 is a Monte Carlo simulation that runs each game 10,000 times to estimate the probability of every possible finals outcome based on their ELO score of the team. So, the ELO system. This is the part that I am really passionate about. I play a lot of chess, so I really wanted to incorporate ELO into sport, and a lot of the research I did showed that ELO is something that is used to predict sport outcomes. So the ELO model was the foundation for all of these predictions. I decided to start every team at 1500 and they gain or lose rating points based on wins, losses, and the margins. I added several adjustments: a finals bonus for qualification, a decay for teams that missed out, and a margin scaling factor. The chart here shows ELO ratings from 2015 to 2025 for the top 8 teams, not including Gold Coast because they haven't made the finals. This was the first year that they did. This captures form over time and highlights strong performers like Geelong, Brisbane, and Collingwood entering 2025. And spoiler alert, 3 of those 3 teams made up the top 4, final 4. The table here compares the predictions from each of my 4 models against the actual 2025 finals results, with the green being the correct predictions. In the first 2 columns, models 1 and 2 show each team's predicted win probabilities. Model 1, the basic logistic regression, performed the best overall, correctly predicting 6 out of the 9 matches. For example, it gave Collingwood an 82% chance in their qualifying final, which matched the actual result. Model 2, which is the ensemble model, was more conservative and often produced probabilities closer to 50%. As you can see with the 2 Adelaide games, of 54% and 56%. It was very 50-50. Which slightly reduces accuracy to around 56% overall. Models 3 and 4 focused on predicting margins. You can see that their average predicted margins were generally within 5 to 10 points of the actual outcomes, which is awesome, particularly in matches like Geelong versus Hawthorn in the preliminary final. You can see that the model predicted 32 and 34 respectively, and the actual margin was 30, which is really cool to get close to those. The grand final result was one of the few major surprises. Both logistic models predicted Geelong, but Brisbane won decisively, as we know, showing how finals unpredictability and momentum can often overcome even the strongest statistical models. Overall, these results highlight that while data models can capture trends and probabilities, sport still has an element of randomness that's impossible to remove entirely. I'd also like to point out with these models, while they don't seem hugely accurate, with accuracy ratings around 50 to 60%, 6 out of 9 games the underdog won, which was the highest priced team. That means that betting companies only got 3 out of 9 correct, and they're meant to be doing this professionally. So I just wanted to caveat that. The simulation procedure used in Model 4 combines ELO-derived probabilities with random variation. For each game, I simulated 10,000 possible outcomes where the score margin varies around the expected value. This gives realistic distributions, and for example, even strong favourites can lose sometimes. The result is a set of probabilities for each team reaching every finals round, including the grand final. So I chose the teams that had the highest probability to make it through. As you can see, it got everything right except for the winners of the grand final, in which it was reversed in this. So it did pretty well, 6 out of 8. So this slide here is going to compare how the 4 models performed and what made some more effective than others. Starting with the outcome models, Model 1, the logistic regression, achieved the highest accuracy at about 66.7% compared to 55.6% for Model 2. The reason Model 1 performed better is because it was simpler and less prone to overfitting. The ensemble model, which averaged results from multiple bootstrap samples, slightly smoothed things out, but also reduced precision. A trade-off that matters when you're working with a small finals dataset. For margin predictions, Model 4, the ELO-based Monte Carlo simulation, provided the most realistic insight, while Model 3 produced reasonable point estimates with an RMSE of around 29 points. It couldn't capture the randomness of finals football. The simulation model, on the other hand, ran 10,000 game iterations, providing not just a predicted score margin, but also a full probability distribution of outcomes. Even though Model 3's exact margins aligned slightly better this year, Model 4 is more flexible and would likely outperform with a larger sample size. Overall, the comparison shows that the most accurate models are not always the most informative. Sometimes the value lies in how well a model captures uncertainty. I'll go back one. So to present these results interactively, I created an R-Shiny dashboard, which I'll show for you now. This is the start, which is the same ELO kind of trend graph that I was showing before. I quite like it, and as you can see, the teams that have kind of dominated over the past 10 years, the ones that have stayed at the top and the ones that did quite well this year. If we go to the next tab, we have the matchup predictor. This is quite cool, I think. So I made it so that you can put in any matchup you want from the top 8 teams. And so you can see how things would have gone down if certain teams had made it through. So here, Collingwood Fremantle, this wasn't a game that happened, but you can see if Collingwood was the home team and Fremantle was the away team, Collingwood would have an 80 to 90% chance of winning based on the 2 models, and it would be quite a large victory for Collingwood. And even just to the casual viewer, this seems pretty accurate. If we were to see that game, Collingwood would most likely dominate that. So you can change these if you wanted to see the Lions versus Geelong. If Brisbane Lions were the home team, which obviously didn't occur, the model actually predicts that they could have had a decent chance, which is cool. So if we move on to Model 1, we can see the predicted probabilities for each of those games. This model particularly didn't really like the Brisbane Lions. It predicted them to lose in every single game. But it got a lot of the matchups correct. So you can see here the 21% win probability is the probability for the home team. So Fremantle had a 21% chance of beating Gold Coast based on this model, meaning Gold Coast were the favourites here. Same here, Hawthorn were the favourites, Gold Coast were the favourites over the Lions, obviously not true. Hawthorn were the favourites, they won, and so on and so forth. So that was Model 1. Model 2, you can see all of the probabilities for that. Model 3, these are the predicted margins for the games. Again, this is the predicted margin for the winners based on Model 1 because they're 2 logistic models. And Model 4 is the simulation as well. So it goes through the 10,000 iterations and then spits out these numbers here. So pretty cool. This is my favorite part of it. It's pretty cool, nice and interactive. You can kind of see all of the cool matchups there. So this is the Shiny dashboard. Awesome. So to finish off, there are several key ways this modelling framework could be improved going forward. First, incorporating player level data, things like injuries, experience, or positional strengths would give a more complete picture of team performance. Something that happened this year was the Crows captain or best player wasn't able to play in the finals due to unforeseen reasons, and I think that really damaged the morale of the team, which is probably contributing to why they went out in straight sets. It would be cool to quantify that. Another thing is adding match-specific context such as venue, travel distance, and head-to-head history, as that would also refine winning probability estimates. For margin predictions, adopting a Bayesian hierarchical model could better capture uncertainty and relationships between games. And finally, expanding the dataset beyond the past decade and including in-season ELO updates would allow the model to adapt faster to emerging teams and changes in form. Together, these steps would move to project from a proof of concept toward a fully dynamic AFL prediction system. To conclude, this project demonstrated how statistical modelling, simulations, and ELO systems can forecast AFL finals outcomes. Each model has its strengths and trade-offs, but together they showed that while we can't remove uncertainty from the sport, we can measure and understand it. Thank you.